some closed interval. The function is x e to the negative x on 2.
This requires you to use derivative time.
Yeah. So we got this guy right here. So I was telling you guys in the last chapter, you're going to be setting these derivatives equal to 0 a lot. Because we're going to be interested in maxes and mins. The way to find maxes and mins is that derivatives equal to 0 and set them undefined. All right? So now you got to solve these equations. It's not just taking product rules and power rules now. You've got to set them equal to 0 and do some algebra. So we have x e to the negative x on 2, and the closed interval is from 0 to 5. Same question. First one. Find all the critical values of f on our interval. Okay? So we've got to take the first derivative. So f prime of x is what? It's product rule, correct? So you have the first times the derivative of the second. You guys are following. Plus the second times the derivative of the first. Agreed? Any questions about that product rule? Because it wasn't that long ago we just learned the product rule. For those who've never seen it before, I mean, it really wasn't that long ago. Okay. We gotta say that equal to 0. So now you gotta solve this equation. How do you solve an equation set equal to 0? What are you gonna do? Factor, that's right, factor. Don't start pushing things to the other side. Factor. What factor does this term and this term have in common?
E, negative 2x. Negative.
All right. What does that leave? It's going to leave negative 1/2 x plus 1. Now we have two factors multiplied together equals 0. That means one or both of these must be 0. Which one is certainly not 0? The other one. E, remember? E is always positive, right? Which one's not going to be 0? This one will not be 0. This is the red herring, right? E to anything is always positive. Right? So forget that one. Don't knock it, don't chop it out of there though, because sometimes you need to look back at your first derivative and you want the whole thing there. Okay? But know that it has nothing to do with making this 0. It's not going to make this 0. Okay? So now we're going to take the negative 1/2 x plus 1. That's the only possibility of equaling 0. We'll subtract 1, divide by negative 1/2, and we'll get 2. Is that right?
Yeah.
Okay. X equals 2. 3? What did you say? 5.
Okay.
20.
That's right. That's right.
What?
All right. I had a class once where I can't remember how it went. I don't remember what it was exactly, but somebody couldn't figure out the answer, and it had to do with powers of 10. So somebody was 10. Somebody was 100, 1,000, sold. It was just so kooky. Whatever. So now x equals 2 is 2 on our interval. Because if it's not, I don't care about it. It is. So I do care about it. So now I have 3 values to care about. The 2 endpoints of the interval and the critical value. So there's our critical value. So now we just check again, the same thing. Go back to f. F of 0, f of 5, f of 2. All right, so let's plug in 0. Plug in 0, the whole thing goes to what? Okay, it's too easy, 0. So now you plug in 5. What does it go to? 5 e to the negative 5/2. Plug in 2, you get 2 e to the negative 1st. I can tell you right now which one's the smallest. Which one? 0. Why? Because this is positive, this is positive, because e's always positive, right?
Yep.
All right, so we know this is the absolute min. I don't have to crunch these numbers to figure out that's the min. Just use logic. So now what absolute max though? It's not as easy. What's that?
I'm just gonna take a guess.
Which one's bigger? This one?
F5.
You think that's bigger, Lou?
Oh, never mind.
F5.
Well, I don't know. I'm just asking you. That's 2 on E, and this is 5 on e to the 5 halves.
Can't you just
Use a log? See what he said?
yeah, just
Why don't you just put it in the
What are you going to apply log to?
drop the -5 to log.
So, okay, an interesting question. Can you apply logs to this and figure anything out?
No.
If you know about logs.
Yeah.
So, remember the log is an increasing, hold on one second. It's important to know a little thing here, Ryan. A log is an increasing function, right? Agreed? It's increasing. So if I put two things into a log, let's say they pop out here and here, right? Let's say this is A and this is B. So which one's bigger, A or B? If that's where they pop out. B. This is a bigger x value than that one, right? So if you apply logs to both of these, and that would help you to see which one is big, meaning which result is bigger, and that means the original one must have been bigger, right? Because the log's an increasing function. So you could do that. So the problem though, Raj, in this case, though, is if you apply a log to this, you'll split it up into log 5 plus log e to the negative 5 halves. So although now you have log of 5 and you free this up, this now says minus 5 halves, but you don't know what log 5 is. You know what I'm saying? You don't know the size of log 5 in your mind, it's no problem. And this one would read log 2 minus 1. So does that help you figure out which one's bigger? Probably not so much because you don't know about log 5 and log 2 the way it should be log 5 and log 2. You know what I mean? So it's still hard to tell. It's an interesting approach though. If they didn't have the 5 and the 2, you'd be able to tell from the beginning anyway. You'd probably be able to figure out from the beginning. But anyway, because exponential is also an increasing function. Okay, so maybe punch the numbers in a calculator and see which one of these two is bigger. Which one is it?
The negative 1. Wait, which one is bigger is the
Yeah.
negative 5 halves.
This one?
Yeah.
That one's bigger?
Yeah.
So that makes sense. I think. Oh no, no, I can't say necessarily. Yeah. How close are they, out of curiosity?
The
No,
5?
you plugged it in wrong.
Oh, crap.
Dear.
Oops.
Maybe you can work it by comparison case.
The bottom one is bigger.
The bottom one's bigger? The 2 on E?
Yeah.
2 on E is bigger?
Yeah.
Oh yeah, I can believe it.
Okay.
I plugged it in right this time.
Oh, you did? Okay. I can believe it, right? How big is E? 2.7 something, right? So-
2 point.
Well, that
E itself is 2.7
Oh.
something, right? So you got 2 over 2.7, which is
it's
around what?
0.7357.
All right, you don't want to think. That's fine. It's fine. Don't worry about it. Don't worry about it. Don't worry about it.
Why not? If you
That's
could
the smallest
plug it
one,
in.
right there. That's the biggest one. Which one bigger? This one bigger? That one bigger.
Yeah.
That
The
one's
computer
bigger.
says so. That's bigger.
That's
Yeah.
bigger.
Yeah, because the machine told you. That's bigger. Well, the machine told you something else a second ago, didn't it?
Wait.
You just didn't put it in right. So maybe you should start thinking more.
Alright.
Whatever.
No,
Anyway.
see, I was smart enough to check it.
That's
twice.
good. Good.
The machine doesn't control me, I control the machine.
Oh, what are you gonna do? When you're stuck on a desert island, what are you gonna do? 41. Same basic idea. Then we need to move on to 42. 41. F of x equals x over the root of 4 minus x